Hello, smart mathematicians. Let's do question 1A1. A jeweler manufacturer measured the diameters of 400 gold spheres produced by machine A and another 400 produced by machine B. The results are represented in the cumulative frequency curves alongside 1A1. Determine the interquartile range for the diameters of gold spheres produced by machine A. Right? How do we find the interquartile range? Remember that the interquartile range is equal to the upper quartile Q3 minus the lower quartile Q1. Then from the cumulative frequency curve, how do we find these two? How do we find the upper quartile and the lower quartile? Remember that the last cumulative frequency value gives you the total number of data items. And then to find the quartile position, we usually use n plus 1 divided by 4 for the lower quartile, let's say Q1 position. But for the OGIVE, it is accurate enough to use n over 4. And then Q3 position, we usually use 3 times n plus 1 divided by 4. But for the OGIVE, we can even use 3 times n over 4. It's still okay. So we're going to use this and this to find the lower quartile position and upper quartile position. Right, our n is 400. We get this from the last cumulative frequency value. So we say the lower quartile is going to be 400 divided by 4, which is the 100th diameter. That's 100th diameter. And then Q3 position, that is 3 times 400 divided by 4. And then we get our 300th position. Okay. And then we come to our cumulative frequency curve and interpolate. 100th position is this one. 100th diameter is 5.8 millimeters. So Q1 is equal to 5.8 millimeters. And then Q3, so this is the 300th position, and then that is diameter of what? 6 millimeters. Q3 is equal to 6 millimeters. And then the interquartile range, remember, is Q3 minus Q1. So the interquartile range is equal to 6 minus 5.8 millimeters. So interquartile range is equal to 0.2 millimeters.